Since the purpose of this Ramchandra Chandravanshi University YouTube channel is to percolate, to diffuse the various ideas, the lectures of the faculties to outside professional world, so that the students of the engineering as well as any other professional, vocational, non-vocational students will be getting benefit. So, being the Vice Chancellor, I just could not resist myself to start one very good lecture so that the various faculty members of various various departments or the colleges of this university will be getting encouraged, and very gradually all the faculty members, they will be sharing their small lectures. So I'll be just now giving the introductory lecture on fluidization engineering. Since my specialization or my field of interest is fluidization engineering, so today I'll be just giving small lecture on fluidization. Fluidization is the unit of operation by means of which fine solids are transformed into fluid-like state through passing some fluid. There are various advantages of fluidization. If it is to be emphasized on the various advantages, before that I have to, on the very outset itself, I have to make a mention what are the various applications of fluidization engineering, fluidization technology. Like for example, just drying or just even distillation. Besides that, drying, distillation, or heat transfer, combustion, gasification, incineration, what are the unit operations I have made a mention just now? Fluidization can be applied. Fluidization technology has to be applied in order to get the advantageous parts of that fluidization. After getting exploited these fluidization advantages, so this can be applied in the industry. Like for example, combustion, that any simple combustion, and obviously heat transfer coefficient will be there in that combustion of coal combustion, and accordingly some thermal power plant that is boiler has to be produced, boiler has to be manufactured, and that boiler will be part and parcel, or rather it is a heart of a just thermal power plant. Now if it is a simple combustion of coal is introduced, or that simple combustion of coal is used in that boiler, the heat transfer, whatever the heat transfer coefficient will be there, and this, in comparison to that heat transfer coefficient, if the fluidized bed technology is used, so it will be having much higher heat transfer coefficient. Now if the higher heat transfer coefficient of this fluidized bed technique, obviously the less number of tubes will be required for just getting the same top steam temperature of a boiler. So less steam tubing is required, so obviously you are getting that economy, it will be more and more economy. Now the second advantage of that fluidized bed technique, for example, if it is confined over that combustion only, I am just not confining over the only combustion. Since my master's as well as my PhD thesis were confined over the fluidized bed combustion of coal basically, and besides that non-conventional coals and non-conventional fuels also can be used for fluidized bed boiler. So what I was saying, that fluidized bed combustion, so since second advantage is that is lower bed temperature is prevailing in the fluidized bed combustion system, like 750 to 850 degrees Celsius is maintained, whereas in the fixed bed boiler or stoker fired boiler, conventional boilers, this is somewhat 1000 1200 degrees Celsius, more than that also it is maintained in the boiler. So because of the very high temperature, obviously corrosion of the tubes or the erosion of the tubes will be taking place, as a result of which very frequent replacement of those tubes have to be made, but which is not there required in case of the fluidized bed technique. In order to get the same top steam temperature, less number of tubes will be required, and as a result of which you understand that economy will be taking place. Much more economy is taking place in this case. Besides the advantages I have just mentioned about that corrosion and erosion, which is more beneficial in case of the fluidized bed technology oriented application, industrial applications, that pollution, this can be achieved, pollution control can be achieved to greater extent using this fluidized bed technology in any industry, starting from combustion, gasification, incineration, drying, leaching, even extraction of edible oil also through that seeds, vegetable oils. This also can be used using this fluidized bed technique. Great advantages may be exploited. And besides that advantages, just I have mentioned corrosion and erosion. In case of the fluidized bed combustion, like pollution control can be achieved much greater extent in using this fluidized bed technology, that is fluidized bed boiler. In fluidized bed boiler, that is that pollution, since the lower bed temperature is prevailing in case of the fluidized bed combustor or the fluidized bed boiler, like even lower bed temperature like 750 degrees Celsius, not more than that. So obviously corrosion or the erosion of those tubes are not valid, and it will not be going to take place, corrosion or erosion. And the pollution, how? Because now sulfur will be there in the coal, that cannot be avoided. When the combustion will be taking place, the sulfur dioxide, that is S plus O2, this gives sulfur dioxide, and that sulfur dioxide, then oxygen reacting with oxygen, it gives sulfur trioxide, and this sulfur dioxide or that sulfur trioxide, this will be emitted through the chimney from the fluidized bed combustor or the fluidized bed boiler. This will be reacting with the moisture content of the atmosphere, that is water, H2O, that gives sulfuric acid. That is nothing but acid mist or acid rain. That is a dangerous pollution takes place. Similarly, nitrogen content of the coal also, that is N2 plus O2, this gives NO, nitric oxide, and then nitrogen dioxide, that also gives the HNO3 if it is emitted, if it is allowed to be emitted in the atmosphere and reacting with water, that is moisture content of that atmosphere, HNO3 will be produced, that is also creating this in HNO3, nitric acid, that is acid mist. So just the advantage of that lower bed temperature of the fluidized bed combustor, this can be just obvious, and using that sulfur in this, that is desulfurization, that is this can be used, can be possible using limestone or dolomite in the boiler itself, in the combustor itself, that is SO2, if it is there, SO2 plus CaO, CaSO4, that way calcium sulfate is precipitated, and this can be taken out from that combustor or the boiler. That is how the pollution can be controlled, and that is because that this is a reversible reaction. In case of the higher bed temperature, this is reversible reaction. The main that is whatever the calcium sulfate will be there, it will be taken back to that SO2, that is reversible reaction. At lower bed temperature, which is prevailed in case of the fluidized bed combustor, so because of that lower bed temperature, this is irreversible process, irreversible reaction only takes place. That's the advantage is to be exploited using this fluidized bed technique. I'll just now continue this way, sharing short lectures on the fluidization engineering topic for the benefit of the overall students, not only for this university, outside this university, our country, as well as throughout the world. The students can get benefit. And if whoever will be liking this type of video lectures. Please don't forget to like and subscribe this university channel. And obviously, I'll be requesting my own university, various faculty members of various departments to share this way small videos, that is lecture videos, through this university channel. Thank you very much.